let's go back to looking at our number line again, and what we can do when we look at our number line or our Argand diagram now, because we have more detail here, is we can see how far away each number is from the origin. Now we're used to doing that, 2 is 2 units away, minus 2 is 2 units back. So this is just indicating the direction that we're going. I is 1 unit away. Minus I is 1 unit away in the other direction. So if we wanted to look at other points though on our Argand diagram that might not be as easy to read, we might look at 2 plus 2i, or you can pick any point that you want. So if I look at 2 plus 2i, I could use trigonometry in order to figure out its distance from the origin, because I know the height of that is 2, I know the length, so the height of that is 2, I know the distance or the length of this is 2, therefore if I connect that up, I'll have a right angle triangle here. That's 2, that's 2, and I can use trigonometry or Pythagoras' theorem to work that out. So we can call this x. X squared is equal to 2 squared plus 2 squared. X squared is equal to 4 plus 4, which is 8. X is equal to 2 root 2. You can throw it into your calculator and it'll give you a decimal if you wanted to. So that's how we can find the distance away a point is from the origin. Any direction you can do it, you can create your triangle and draw it. We also might look at the angle that is met with this line now. So this is called the modulus. Okay, if they told me z is the point 2 plus 2i, and they wrote this, that's the symbol for modulus. So the modulus of that we just figured out is 2 root 2. And we could find the angle that this point is making with the positive side of the x-axis. So again, I'll use trigonometry to find that angle. It's 2 over 2, and I'm using opposite and adjacent, so that's tan. So the tan of the angle is 2 over 2. So I use inverse tan of 2 over 2, and I get 45 degrees. So the angle that this is making here with the positive side of the x-axis is 45 degrees. Again, you just use your trigonometry to find any point here. So now that we've looked at that, instead of plotting points here on my Argand diagram, like let's say minus 2 plus I, if we're looking at that, and calling out that point there in terms of what's called rectangular form. Okay, I'm creating a rectangle, so that's just called rectangular form. We could also look at the point in terms of how far away it is from the origin and the angle that it's making with the positive side of the x-axis. And if we do that, if we look at it in terms of that, we're going to call that looking at it in terms of polar form. If you go to your log tables, polar form is r times the cos of theta plus I sine theta. Theta is your argument, your angle here, and r is your modulus or distance from the origin. If you fill that in, that's another way of describing your points on your diagram. Okay, the plus side of rectangular form is that it's easy to read. Okay, very basic. The plus side of what we call polar form is to do with the fact that when we write a point in polar form, we can use what's called De Moivre's theorem in order to help us work with the point and perhaps maybe multiply points or get this number and put it to the power of 3, or put it, multiply it by itself 4 times. So rectangular form has its pluses because it's a nice straightforward way to describe something, but so does polar form. We also have something called general polar form, I mean, I could describe that with the angle being 45 degrees away from the positive side of the x-axis. But I could also describe it as 405 degrees away from the positive side of the x-axis. Okay, maybe I just don't want to go on 45 degrees. Perhaps I could say I'm going to go around once, which is 360, plus 45 degrees. So I could describe it in that manner. Or I could describe it, you know, going backwards, however many rotations. So if we want to be a bit more general as to how we're going to describe that point, then we can use general polar form. Okay, this is more general because it could be the 45 plus 360 degrees, however many rotations I want. So n is an element of z. You know, I'm going to go a full rotation or back a full rotation to describe that point. So this number here, 2 plus 2i, if I want to describe it in polar form, it'd be 2 root 2 times the cos of 45 degrees. Now usually when we're in polar form we're going to put it into radians, so that's pi over 4 plus I sine pi over 4. And if I wanted to get that and put it into general polar form, it would be 2 root 2 times the cos of pi over 4 plus 2 pi n plus I sine pi over 4 plus 2 pi n. And again, n is an element of z. So we have reasons for wanting to describe it in rectangular form, reasons for putting it into polar form, and we will get to the reason as to why we would want to be able to put it into general polar form in questions. But you need to be able to work with any number and put it into polar form or general polar form, or take it out of them and put it into rectangular form.